Hello students, we are solving chapter 3 current electricity questions, and student, you can find out the link of solution of all questions of this exercise below the description box. And also students, we have solved the all questions of EXEMPLAR chapter 32 electric current in questions. EXEMPLAR, you know, that's important for all students who are preparing for IIT or NEET, or if any plan in future for preparation of these examinations. So let us start our today's class. And students, if you are new on this channel, please subscribe my channel. Thank you. Now student, question number 3.11. This question is saying a storage battery of EMF 8 volt and internal resistance 0.5 ohm is being charged by a 120 volt DC supply using a series resistor of 15.5 ohm. Student, we have a battery having EMF E 8 volt and internal resistance normally represented by a small r having value 0.5 ohm, and this battery is being charged by a DC supply of value 120 volt, which is in turn connected with a resistor let having resistance capital R, and its value is also given 15.5 ohm in series like this. Okay, this is the situation, student. Now the question is asking what is the terminal voltage of the battery during charging. Terminal voltage, student, let if this point is P and if this point is Q, then what is terminal voltage? Terminal voltage of battery. Terminal voltage of battery means what? Potential difference between points P and Q. This is the terminal voltage of battery, means potential difference between points P and Q. Okay, student. Now means we have to finally find out the potential difference between point P and Q, and obviously you can understand that for finding potential difference between points P and Q, you will have to certainly find out the value of current flowing in the circuit. Only then we can find the potential drop across this resistance using Ohm's law, V equals to IR. Means finally we have to anyhow find the value of current I. One thing. Student, second thing, always remember, since the battery, this battery having EMF 8 volt, internal resistance 0.5 ohm is in charging condition, so always remember, for charging any battery we connect the positive terminal of battery with the positive terminal of supply voltage, In other words, in other way, if you have to check that in any particular situation whether a battery is in charging or discharging condition, then how will you find it? How will you check it? Then very easy, just see if current entering the battery, if current is entering the battery through its positive terminal, current is entering the battery through its positive terminal, then it means the battery is being charged. Otherwise, discharging condition. Okay. Now, so here on this argument, on this basis, you can decide that the current flowing in the circuit will have clockwise direction like this, so that the battery will enter inside the battery through its positive terminal. Okay, student. Now, so for finding current, you can see that here equivalent resistance in the circuit. The equivalent resistance in the circuit is 0.5 ohm plus 15.5 ohm. 0.5 plus 15.5, this becomes 16 ohm, and effective equivalent EMF, this is 120 minus 8, this becomes 112 volt. So I is what? Current flowing in the circuit. This you can write from Ohm's law, E equivalent divided by R equivalent. This is 112 by 16, and this becomes 7 ampere. Student, you can also find out the value of current using Kirchhoff's voltage law. R, just see here, R using KVL, Kirchhoff's voltage law or Kirchhoff's second law. We also say it, Kirchhoff's second law, like this. Just write down the equation. Okay, potential difference across all the elements and equation, and this will turn equal to 0. Okay? Now you are moving through this side, and moving through this side and facing positive terminal of battery, so we will take positive sign, means 8. Now again we are moving this side, current is also moving this side, so again we will take positive sign for writing the potential difference across this resistance, and this will be IR, I into 0.5 using Ohm's law. Okay, now again we are moving this side, current is also moving this side, so again we will take positive sign IR, I into resistance 15.5. Again we are moving this side and we face negative plate of battery, negative plate of this source, so we will take minus sign with value 120 volt equals to 0. And when you will solve this equation, again you will get the same value of I, that is 7 ampere. Okay student, now potential difference इसीलिए show terminal voltage of battery is what? Vp minus Vq is what? Vp minus Vq. Again let us start to move from point B, from point P towards point Q, facing first positive plate of battery, so take positive sign, means E. Okay, now again we are moving this side, current is also moving this side, so plus sign, and so IR. Okay, E plus I, and now put the values of all these terms. E 8 plus I 7 ampere, R is 0.5, this becomes 8 plus 3.5, this becomes 11.5 volt is your answer. Okay student, okay, it's formula based easy question. Now let us move towards question number 3.12 student. There was also another part. What is the purpose of having a series resistor in the charging circuit? In this charging circuit, why were we using this series resistance? Why were we using? Because it seems that even if we don't use this resistance, then battery may still charged using this DC supply voltage having higher value 120 volt. Okay, no problem, no need of this resistor. Then why we use this series resistance? Student, you can understand, if you don't, just suppose if you will not use this resistance, then the current flowing in this circuit, if R will be not used, let us check. If we don't use this resistance, then the value of current flowing in the circuit will be I equals to 120 minus 8 equivalent EMF divided by equivalent resistance 0.5 ohm, because now in this case R we are not using, so equivalent resistance 0.5, this becomes 112 by 0.5, and this becomes 224 ampere. You can see it's very clear that if you don't use this resistance, then the current flowing in the circuit has very high value, 224 ampere, where just see previous case when we were using this resistance, then the current flowing in the circuit had very less value, 7 ampere. What will happen if this higher value of current, very high value of current will flow in the circuit? In this case, very high value of heat will generate through this internal resistance I square R. Just imagine a square, it's a square value, means finally very high amount of heat will produce through this internal resistance, and finally there will be chance of damaging this battery, and this is why we use a series resistor for charging any battery. Okay student, now let us move towards question number 3.12. 3.12. Student, this question is saying, in a potentiometer arrangement, a cell of EMF 1.2 volt gives a balance point at 35 centimeter length of the wire. Okay, we are solving question number 3.12. In a potentiometer, you have studied potentiometer theory. In potentiometer, it is saying that if we use a battery of EMF 1.2 volt, then we get balancing length at a point L1 equals to 35 centimeter. Okay, and question is further saying if the cell is replaced by another cell and the balance point shifts to 63 centimeter, what is the EMF of the second cell? Now the question is saying if we replace this battery having EMF 1.2 volt with another battery, say EMF E2, then we get the balancing length L2 equals to 63 centimeter. Then we have to find the value of EMF of this second cell. Okay, student, you know very well that in case of potentiometer, here we can write E1 by E2 equals to L1 by L2. In fact, how we write this relation, you can understand. In case of balancing length, the EMF becomes directly proportional to balancing length L1, means you can write E1 equals to KL1. Similarly, for second cell, you can write E2 equals to KL2. Okay, and when you will divide these two, then this K will cancel out and finally you will get this relation E1 by E2 equals to L1 by L2. And so now putting all the values of these terms, 1.25 divided by E2 equals to 35 divided by 63. This becomes, this you can further write 5 by 9. This E2 equals to 9 into 1.25 divided by 5. This is 9 into 0.25. This is 2.25 volt. 2.25 volt is your final answer. Question number 3.12 we are solving. Okay, student. Now, easy question, formula based question. Okay, student. We will now further meet in next class with solution of questions of waste questions. Thank you.